In this video, we will derive the expression of the electric potential at any point due to an electric dipole. We already know what is the meaning of an electric dipole. Electric dipole is the combination of two equal and opposite charges separated by certain distance apart. So, let us first understand the diagram before starting our derivation work. See, here AB is a electric dipole situated along the x-axis of the coordinate system. Here minus q charge of the dipole is situated at A, plus q charge of the dipole is situated at the point B, and the distance between the two charges and O is the center of the dipole. As O is the center of the dipole, so OB is equal to L, and also AO is equal to L. Here this line ABX line is the axial line of the dipole. This is the axial line of the dipole. Axial line, this ABX line, and this line OY is the equatorial line of the dipole. OY is the equatorial line of the dipole, and P is any arbitrary point situated inside the electric field of the dipole where we want to find the electric potential, and this point P is situated at a distance r from the center of the dipole, that is OP distance is equal to r. So this is all about the diagram. So again I am telling that AB is a dipole. Here minus q charge is situated at A, plus q charge is situated at B, and P is any arbitrary point situated at a distance r from the center O of the dipole. The distance between the two poles of the dipole is equal to 2L, and here OB is equal to L and OA is equal to L as O is the center of the dipole, and the dipole is situated along the x-axis of the coordinate system. So now let us start the derivation work. Let BC be perpendicular to OP, and AD be perpendicular to OP extended, and the angle POB that is equal to angle AOD is equal to theta. So this angle is equal to theta, this angle is equal to theta. Now see, this AO is equal to L and OB is equal to L. Then As this is a perpendicular and this is also perpendicular, so see in this triangle OBC, OC is equal to L cos theta. Similarly, as ADO is a perpendicular, so OD is equal to also L cos theta. Now AP is equal to how much? AP is equal to, from the diagram, see in the diagram AP is equal to PD, but PD is equal to OP plus OD. Here OP is equal to R, as the observation point P is situated at a distance R from the center of the dipole, plus OD is equal to L cos theta. Similarly, in the diagram PC is equal to PC. Similarly, in the diagram PB is equal to PC. This is equal to PO minus OC. So this is equal to PO is equal to R minus OC is equal to again L cos theta. Now let us write this as equation number 1 and this one as equation number 2. Now if V is the electric potential at the point P, then the electric potential at P due to the dipole that is V is equal to, we know that the electric potential at the point due to a single point charge or electric potential at P due to the charge plus Q is equal to 1 by 4 pi epsilon naught. Here the charge is plus Q divided by PB, the distance from the charge plus Q, plus electric potential at P due to the charge minus Q, that is 1 by 4 pi epsilon naught minus Q divided by AP. But we already have already calculated the value of PB and AP. So let us put those values here. So this is equal to next step is 1 by 4 pi epsilon naught Q divided by the value of PB is R minus L cos theta. This is a minus 1 by 4 pi epsilon naught Q divided by AP is equal to R plus L cos theta. So this is equal to, here q by 4 pi epsilon naught is common, into 1 divided by r minus L cos theta minus 1 divided by r plus L cos theta. This can be written as, this is equal to q by 4 pi epsilon naught r minus L cos theta into r plus L cos theta into r plus L cos theta minus r minus L cos theta. So this is equal to q divided by 4 pi epsilon naught into a minus b into a plus b, and the formula is a square minus b square, so r square minus L square cos square theta. Here r plus L cos theta minus r plus L cos theta, r will be cancelled out, so this is equal to 2L cos theta but we know that r is very large than that of a L. So r square again is very large than L square cos square theta. We know that the maximum value of cos theta is 1. So as r is very large than L, so r square is also very large than L square cos square theta. Now we can ignore L square cos square theta in the above equation. Let this be written as equation number 3. Let us write this as equation number 3. So this implies V is equal to Q divided by 4 pi epsilon naught 2L cos theta divided by r square. This is equal to 1 by 4 pi epsilon naught. This is Q into 2L cos theta divided by r square. So Q into 2L, that is Q is the magnitude of either charge and 2L is the separation between the two charges. So we know that this value is the magnitude of the electric dipole moment. So we can write this 1 by 4 pi epsilon naught P small p into cos theta divided by r square. This is the final expression. That is, this implies V is equal to, or the electric potential at any point due to an electric dipole is equal to 1 by 4 pi epsilon naught. P is the dipole moment, P cos theta divided by r square. Let us write this as equation number 4. Now, when the point P lies on the along the axial line, or along the x-axis in this particular figure. So case 1, when the point P lies on the axial line of the dipole. See, then theta is equal to, theta will be what? As the point P. If the point P lies on the axial line of the dipole, see, in this figure, if the point P lies, suppose the point P lies here, it is the axial line, then theta will be equal to 0. Again, if the point P lies on the equatorial line, then theta will be equal to 90 degree. Let us put those values. So when the point P lies on the axial line of the dipole, that is theta is equal to 0 degree. Then equation 4 will be, as theta is equal to 0 degree, then cos 0 degree, we know that cos 0 degree is equal to 1. So cos theta is equal to 1. So this implies the equation 4 will be equal to V is equal to 1 by 4 pi epsilon naught P divided by R square, as here cos theta will be equal to 1. So this is the expression of the electric potential at any point on the axial line of the dipole. So it is the expression of electric potential at any point on the axial line of the dipole. Similarly, case 2, when the point P lies on the equatorial line of the dipole. That is theta is equal to 90 degree. Then cos theta is equal to 0. We know that cos 90 degree is equal to 0. So then equation 4 will be, in equation 4, if we will put cos theta is equal to 0, then V will also be equal to 0. So from this we can conclude that electric potential at any point on the equatorial line of the dipole is 0. So electric potential at any point on the equatorial line of the dipole is 0.